Well, so thanks. Welcome everyone, first of all, to the second online meeting that we organize here in Connected Data London, even though, London is a kind of relative term, because none of us five people who are joining this panel today is actually based in London. And well, this is the upside of having a virtual panel instead of face-to-face one, which was the original idea behind this panel. So just to share with a little bit with the world. So the panel we're having today is about a 2020 vision for the semantic web. And it all started basically, again, virtually. So a Twitter thread, an exchange between us that we were planning to actually meet in Athens and have this panel as a real live discussion. Well, since we're not going to be able to do that, we thought we might as well do that. We can still have the discussion even remotely. So this is the idea behind today's panel. So with that, I'm going to switch to hand over basically to David, who will be moderating. I only have one last thing to say before that, which is to thank our sponsors today, Brimhill Computers. And Brimhill Computers are the makers of Servo, which is a software intelligence tool that analyzes and investigates running applications. Servo is a Python agent and a web interface aiming to understand existing information systems and legacy applications. And again, many thanks for sponsoring today. And without further ado, David, it's on to you, and happy moderating. And let's all enjoy the conversation.
Thank you very much. Okay, a quick introduction, basically, both to the subject matter and to our subject experts today. And in no particular order, the experts are George Anadiotis, who has written extensively about the semantic web. He knows about graphs and has extensive experience in the online world. We have Theodora Petkova, and she has written a book about how text changes in the semantic web, how all these links and changes in the way that we communicate. We have Panos Alexopoulos, who is part of OntoText, and he's an expert in ontology building. And for those of you, sorry, yes?
I'm not part of OntoText.
I'm sorry.
There is some text in the company he works for. It's called Text Kernel, so that's right. Close enough.
Yes. I'm sorry, Panos. I apologize. And he's an expert in ontology building, and I'm correct in this, right? And for those of you who are not familiar with ontologies, which is a slightly philosophical subject, which has real-world applications, it's the way that things are classified in the web and how we actually put things together. And finally, we have Professor Amit Sheth with us, who is an expert in quite a wide variety of things, from entrepreneurship to artificial intelligence and the semantic web, and how those technologies come together. Today's subject, which is essentially what is happening in the semantic web, it's a state of play in many ways. We're looking at 20 years of progress, and also we're trying to find out what the next step will be. So we've got some questions to start off with, which will help guide the discussion. And any of you attending now, if you have any kind of questions as we progress, if you ask them of the panel, I will try to bring them in, and I'll try to give you answers in real time. So let's begin with the first question. And the first question is, we have 20 years of semantic web building in the 21st century. It's come from the limelight to obscurity and back again. Has this taught us anything about how the semantic web works? And does it give us perhaps an inkling of how it's going to progress? And we'll take this question perhaps to George, if George, that's okay with you, George?
Yeah, it's fine. Okay. And actually, I can use the opportunity to say a little bit about how I got hooked, let's say, on the semantic web. And even though I'm not one of the few of the people that actually got it started, like Amit is, for example, I was a kind of early adopter, let's say. And the thing that attracted me back then was actually, if you are the people in the audience who may be familiar with what we call the semantic web cake or stack, it's a kind of layer of functionalities that when the semantic web first was prescribed, let's say, was supposed to show the different layers of the functionality and how it's going to work. And you have things such as IRIs at the bottom, so standards that help you locate things, basically, and then you kind of build on that. Actually, the part of the stack that attracted me the most was one that hasn't yet been implemented, actually, and that was the agent part. So I was very much attracted by the ability to have different agents. In my mind, I pictured them back then as kind of acting on behalf of the user, who would be able to get the preferences of the user, the cognitive domain of the user, and the underlying layers would be the ones that kind of encoded this knowledge and would be able to act and negotiate and perform different actions on behalf of the user in a distributed way. It was ambitious back then. It's still ambitious today, and which is why it hasn't been fully realized. But this is the part that attracted me. So to go back to the question, going back to from the limelight to obscurity and back again has taught us. I would say it has taught us a number of things, and I would basically start with the ambition. And when you have something like this, which has been initiated and advocated by someone like Sir Tim Berners-Lee, who's credited with the invention of the web, and to a large extent, he has been behind the semantic web as well. Well, ambition, lack of ambition is definitely not an issue. Maybe actually it was a bit on the other side of the spectrum, so a bit over ambitious, let's say. Looking at this today, from the standpoint of almost 20 years after, it was, this vision was way ahead of its time. So this is one thing, when we talk about the semantic web, I don't know, failing or succeeding or whatever, today we have the luxury of doing that almost 2 decades after it was initially conceived. So we have to, we have to put that into perspective. And even though, some parts of the stack were not fully realized on this part, other parts were and are very, very useful today, and people actually use them every day, even though they may not realize it. For a stack, this is actually a good thing, not realizing that you're using it. So in that sense, it's a success. So I would say that this is another takeaway. If you make the technology go in the background so that people don't explicitly have to use it, then I would call it a success. It brings better adoption. But I think I've already said enough. I mean, I could go on and on, but I'm sure the other panelists will have something to say on that too.
That's great. Thank you very much for that perspective. And I think it sort of covered a lot of things in a fairly spherical way. So it gives a nice grounding to where we are at now. So let's, we mentioned that the semantic web began fairly strongly as an idea, then it faded into obscurity, and then it came back. Now, the question that arises from this, is it just a perceptual rebranding and some pragmatism that was required, or do we need something deeper here? And perhaps Theodora would like to try this?
Yes, sure. I just want to, I have something to say about fade into obscurity. The semantic web never faded into obscurity. It was, I mean, also I'm thinking about why do we say that it's 20 years from the semantic web. Just reminding about a 94 presentation of Tim Berners-Lee in Geneva, where he talks about the way content needs to be described for machines so that the web is not flat for them, and we can give meaning to machines. So if the idea of fading into obscurity of something that is 30 years old is a bit, I don't know, I don't like the framing. The framing, I would go with what an exciting thing the web is, and the web will never be done. The same as with the semantic web. It will never be done. It's a way forward. And as Professor Shet wrote a beautiful article about building knowledge graphs, it takes 100 hands or 1,000 hands to build a knowledge graph. So the semantic web would take a lot more and a lot more coherence and debate. And finally, I didn't answer your question, David. What was your question?
Well, the question was, and I will also ask Amit to add to this. The question was that perceptually, in order for us to begin to actually thinking about the semantic web in a broader context with a much larger base of people, was all that was required a case of rebranding it so that it becomes perhaps more accessible?
No, I don't think it was it's a matter of rebranding it. So I was in this area. I started at my first paper. I can actually show that had the same concept as semantic web was 1994, published in CIKM conference, which had multiple ontologies and use of ontologies to access data, heterogeneous databases. So that was the paper, and that was 1994. Unfortunately, I used the word semantic information brokering to call whatever I meant. The word semantic web was far, I guess, catchy, and it came from Tim Berners-Lee. Now, following the reason why a semantic web did not succeed a whole lot as much as people thought was that there are too much. First of all, semantic web was two communities. So one was people who went for logic and who went for completeness of knowledge, and we went for reasoning. And other were people who already understood the value of the knowledge and use of knowledge in applications, processing, search, and things of that nature. 1999, I started my second company, which was a semantic web company, the first semantic web company, and we got the first patent with semantic web in the title in 2001. It was filed in the year 2000. So semantic web for semantic search, browsing, personalization, and advertisement. That was what the patent was about. And the fundamental thing about the patent was that I choose the more practical route compared to the year 2000 paper, but Tim Berners-Lee Handler paper, which talked about agents and logic and decision making. This was about creating a very large, we used to call world model or ontology, but fundamentally same as knowledge graph, in the sense that it was much more practical representation of knowledge that did not seek the completeness, that did not require logic and other foundation. The reasoning being this very practical aspect. How many people are taught logic and like to use logic after they graduate? And how many people are taught graph and such data structure and they can use those such data structure after they graduate? And the second thing is that being able to create knowledge that is not perfectly accurate, but is large enough to capture a lot of things has much bigger value than working very hard to create a small knowledge base that is very consistent and complete, and you can have theoretical provable capabilities. So we've built a search engine. My company, the company I founded still survives, except that because of the internal bubble burst, we had to become vertical market focused. So it only works in the financial services market. Then what happened is that in the first 5 to 10 years of semantic web, a lot of things happen with OWL and description logic and many things like that. There's nothing that has really succeeded from that line of work, or very little that has succeeded.
And I think I'm sorry to interrupt, for the benefit of the people who may not be familiar with it, OWL is a language which is used to essentially code specific aspects of it.
Yeah, the knowledge, to represent the knowledge. OWL is used, the web ontology language is to represent that. But there was a lighter version of that also Tim Berners-Lee recognized, not in year 2000, but in around, in 3, 4, 5 years later, and he really got into this linked data. That ended up being a lot more practical aspect of the semantic web. That has survived very well. Now, rather than giving a very long answer, I'll give very simple and straight answer. Why is what we want to call semantic web back? Many people will not give semantic web a credit for what is happening in the knowledge graph related work. Nevertheless, we like to take a credit because I had a patent on semantic web that had knowledge graph, and others also worked on that. The reason is that people have recognized a fundamental value of knowledge. In year 2012, this deep learning happened. Before that, it was machine learning, and much of the AI was all about machine learning and deep learning, a little bit about NLP. Now they have reached the limit, much of it, in NLP and machine learning and deep learning, and everybody's recognized that knowledge is power, and it is whatever investment you need to make is worth making the investment, because Google proved it. In year 2012, they started with Freebase and created this knowledge graph, and since then, 2013 in semantic search, you can't think of search without knowledge graph. So the value was so overwhelming that whatever is the investment to create knowledge graph is worth it. And that now is really has taken over. So every company basically has their own knowledge graph, or they're licensing knowledge graph from somebody else. And they feel that the investment they're making it is still well worth it. I have a student, I'll end up with just one observation. I have a student who went to Amazon last year.
Yeah.
And he calls up and says, Dr. Seth, around me, I can't find a single project that does not use knowledge graph. So if to the extent that semantic web can take credit for knowledge graph based ecosystem, I'm happy to describe that later on.
Okay.
That exception, this has really succeeded now.
Perfect. That's really good. Panos,
Maybe
yes, indeed. Yes, absolutely. Yes, you can.
I think what Amit said is very correct, but I'd like to clarify something, at least on my perspective.
Definitely, yes.
A knowledge graph, what we are witnessing right now this year is the coming back, not of the semantic web, in my opinion, but coming back the power of symbolic knowledge and reasoning. The semantic web started in 1994, but 10 years before, in the 80s, there were already the idea of semantic networks, of expert systems back then, etc. So it's a bit inaccurate to say that it's the semantic web that brought this into existence. What semantic web tried to do is bring that into a large scale, right? By creating some standards based on which anyone can do that at the web level. And to some extent, what we're witnessing right now is the larger scale of knowledge graph. So instead of having a small ontology or a small knowledge graph of a couple hundred of entities, we have millions of entities. Mm-hmm. But on the other hand, I really doubt whether we have semantic interoperability. So whether, for instance, the knowledge graph of, I don't know, a company like Thomson Reuters is really semantic interoperable with the knowledge graph of JP Morgan, for instance, if they have any.
Basically, knowledge is still trapped in silos. All those silos are perhaps a little...
Yeah, we call enterprise knowledge graph. That's why the term enterprise knowledge graph is coming to picture.
Yes, for instance. So I think what we're witnessing now, at least the way I have seen it in the enterprise level, because this is where I mostly work, is that indeed, because of the limitations that exist in the machine learning approaches, etc., we still need domain knowledge, we still need symbolic knowledge and reasoning to enhance this. So companies now have additional incentives to do that, because they have realized that, we have all these amounts of data. It's not enough to put them in a data lake and just run analytics over them, right? We need a semantic layer that will tell us what these are about, right? This is partially...
We're still on.
Sorry, can you hear me? Yeah. Can you hear me?
Yeah. Yes, certainly. We hear you.
So this is partially the vision of the semantic web, but also the semantic web had other aspects that are not necessarily followed now. So to give you an example, semantic web is all about the open world assumption, which is something that I don't think many companies would like to use. That's why Shackle came arose the last couple of years, right? Or the semantic web is about interlinking data, right? That there is this mantra that interlinking is good. We need to link data. Personally, I'm very careful what I link my knowledge graph to, right? Because it's not that simple. it's not that simple to ensure that just by using semantic web standards and interlinking data, you ensure that everything is nice and everything is correct. Right? So that's my 5 cents. David cannot hear us? No?
Yeah, we can hear you. So David, you're...
Yeah.
Maybe David has some problems.
Just to add to what Panos said, and actually I think something that none of us highlighted explicitly up to this point, which is the connection, let's say, between knowledge graphs and the semantic web, because I guess most people, not necessarily in this audience, because it probably attracted a kind of special niche possibly, but most people these days are quite familiar with knowledge graphs, while they're not necessarily equally familiar with the semantic web. Well, knowledge graphs are entirely based on not just the semantic web approach, but in many, many cases on the semantic web technology as well. Even though, this is not an absolute requirement, it's basically the same thing. This is why we talked about rebranding earlier.
Yeah, and partly that is, to some extent, is true because, for example, one very widely used knowledge is schema.org. And there is kind of some aspect of what we, standardization work that we have done that gets reflected there. One very common knowledge graph that almost everybody uses is the knowledge graph extracted from Wikipedia, the DBpedia. And again, there is use of one of my former PhD students implemented DBpedia, DBpedia tool. That also use semantic web technologies.
Amit, can I ask you something? Do you know any company that uses DBpedia for profit? I mean, for a way that to serve clients and trusts DBpedia, its quality and all aspects, right? Because it doesn't really have control over DBpedia. So I'm wondering, do you know anything?
All the search companies, I just in fact saw somebody who came up with the knowledge panel. And the knowledge panel is the first version of the knowledge panel is all based on Wikipedia. So in the search context, they are really monetizing Wikipedia in whatever they are doing. They basically anything that is consumer facing. There is extensive use of Wikipedia and DBpedia. When it is business, customer facing, then they build their own stuff. Okay, David, are you?
I think David has connection problems. So.
Oh, okay. Then I think you want to, George, take the next question?
Yeah, since actually Theodora, you were supposed to be given that one, and somehow we lost the flow in the process. So your point on whether the semantic web should be framed as having gone to obscurity was well taken. But I think you may actually wanted to address the question that was framed by David, which is what. Going back and forth, let's say, let's not use the word obscurity since you made the point of that. But basically, what happened with the semantic web was that when it was first introduced, let's say, there were high hopes about it, but actually, I would argue that this basically happens with pretty much all technology. When it's first introduced, it means everything to everyone, and everybody expects it to be the greatest thing, and to do that immediately within the next couple of years. And of course, when this doesn't happen, there's this kind of disappointment, let's say. So for a while, this happened to the semantic web, and it's also the additional aspect that it has in some ways and for some reason being associated, connected to having an academic approach, whatever that may mean. We're going to touch on that further on, but for very real reasons, the semantic web has kind of lost its appeal. And so now we're saying that it's making a comeback under a different name, hence the reference to, knowledge graphs and all this kind of terminology. So the question to you, after this very long introduction, is: so what do you think that this course has taught us, if anything? From going from being the next best thing to disillusionment, and now actually seeing some actual real world adoption.
Mm-hmm. Thanks for the question. And I was thinking about this, about the high hopes about the semantic web, and maybe because I'm not into the gist of it like Panos is, and I totally agree with all of the points he made, that for example, who uses DBpedia? I think the argument there, and Panos, please correct me if I'm wrong, is that the data there is dirty. Not dirty, but you need to clean the data and work a lot on the data in DBpedia as to use it as part of your knowledge graph. Is this what you meant?
Yeah, so it's the quality in general. It's not only accuracy. It's accuracy plus context plus what it is useful for. So it's not only when it comes to a knowledge graph for a particular purpose. It's not only what it contains initially, but how it is governed and how it is evolved, right? And one thing that you can control, or you want to control when you use a knowledge graph, is its evolution. You want to go towards the direction you want. So if DBpedia has 100 domains, who decides what domain will be covered next, or will be, right? Mm-hmm. So from this perspective, that's important.
It is very important. And I use it to make my point that, again, it's a shared effort. And it takes effort. And yes, it takes money. And yes, it's not something easy, the semantic web. And about the high hopes, I can't think of any higher purpose than mapping knowledge in a machine readable way. So whatever we do, we are to bump into challenges, the challenges of the knowledge soup and the challenges of learn to think together. This is regarding the question about academia and business. I'm facing the same challenge with academic literature sometimes not being very coherent with business practices. But why don't we just leave this as it is, like academia for thinking and business for trying to translate this thinking into actions? Of course, there will be discrepancies, and then let's handle them.
I think that in AI Institute, which I have now, we do a lot of real world projects in medicine and public health and many other things. So I don't think that, that it's not a straight, some of us are as practical as industry may be. I currently have 3 companies that use knowledge graph one way or another that I founded. So there's no such, strong distinction. One point I would like to make is that, look, the knowledge that is created by collective work, as in Wikipedia or as in schema.org, is essentially free because everybody chips in a little bit. It has its limitation, but because it is free, it is going to be widely used, and it is being widely used. And then there is a need for specialized knowledge. You need to go deep into a subject area that a public knowledge source like Wikipedia won't be appropriate. We were developing a knowledge graph for human performance and cognition. Well, that's a specialized field, and there is only so much about human performance and cognition, dopamine and other chemicals, and how brain works on those kind of things. That is in Wikipedia. So then we have to go and really invest our own time and effort to develop and flush out, to give the details and depth that is necessary to use. But we actually use skeletal information just to get started from Wikipedia. And then we went on to mine knowledge from very specific literature in that domain to create that highly specialized knowledge graph. So I think both of them can work together. There isn't any, there doesn't have to be very strict deadline, distinction we could do. What I think academia has to do much better than it has done in the past is to give us the trained manpower, people who are trained to develop the systems along semantic web and or knowledge graph based technologies. There are too many people being trained for machine learning, too few for knowledge centric ecosystem.
Yeah. If I may add to that, I mean, that was exactly what I wanted to say. I mean, as far as the tension, let's say, between academia and industry goes. So, I mean, this exists anyway, regardless of the domain. But in this case here, we're talking about a very specific domain. As Theodora pointed out earlier, we're talking about capturing knowledge. And this makes, in my opinion, makes the tension even more pronounced, because academia is specifically trained and geared towards doing precisely that. And, this kind of analytical thinking and abstraction and so on and so forth. Business on the industry, on the other hand, has a totally different approach, more practical, goal-oriented, and in many times that also means cutting corners and not actually investing enough in seeing the bigger picture and actually documenting that. So this is already a kind of tension in terms of approach. And if you add to that the very specific issues that have to do with software development. So this is something that, admittedly, industry is much better at for a number of reasons. I mean, it's not actually the main job of academics is not to build software. So they haven't, many of them, haven't had proper training in that and haven't actually had the experience of building, industrial strength software systems and so on. Plus, in academia, there is a high churn level. So people don't stay long enough in a certain position to be able, to develop the skills. And there is no actual business model in academia. This also has a lot to do, if you're building a software product, you need to think about, things such as how is it going to appeal to users? How am I going to market it? And all of these things. These things are not in the mindset of academics. And, rightfully so, I would say, it's not their job to do these things. But for a long time, the software development that related to the semantic web was more or less in the hands of academics, or people who were directly out of academia, and that had a very real, I would say, effect in the quality of the software. And so many people who got exposed to the software that came out, of the semantic web camp, let's say, around that time, got disillusioned. And, some of them may have returned, others just stayed with that impression of, it's the software just doesn't work, and they just walked away. Hopefully, they may return by now, because by now there's a ton of vendors that use semantic web technology, and they do a very, very good job. But, it's a kind of, you have to change that preconception in order to make it work.
We have a couple of questions which perhaps should be addressed from the chat. One of them is, the first one is practical. It's from Hamad, and he's asking, how does GDPR apply to data management, especially knowledge graphs? Somebody would like to pick this up? Amit, yes, go.
So, in the knowledge graph, it depends on how you define it. I'll give you an example. We developed an application that was about electronic medical records, and we had knowledge graph about how drugs, about the medical drugs, and in that drug-to-drug interaction, for example, was modeled as rules added to the ontological concept. Okay. Now, similarly, GDPR can be translated, can be represented as constraints and rules that may, that will constrain on the utilization of the data. So if the data is personally identifiable data, then you're going to do something or the other. And for that, you can think of it as a enhancement of knowledge graph or a layer over knowledge graph to capture these kind of rules and regulations that can then constrain on the use of the data.
Does this, what you're describing, Amit, does this reflect a little bit on what Panos described earlier when he said that there's a lot of company knowledge graphs which are essentially siloed and there's no interoperability in the data from one knowledge graph to another for various reasons?
No, all I was basically saying is that the composition of knowledge graph, when you talk about knowledge, you can limit it to simply the facts. That's the core of knowledge graph, but you can also incorporate in that the actions that you can take using that knowledge. Right. Or the actions of creating the knowledge and storing certain data. Those can be modeled and can be called as part of the knowledge graph, and hence the answer to Hamad would be that some of the companies could choose to codify GDPR as part of their knowledge graph representation, extension of knowledge graph, and hence consistently deploy it better, rather than keep the GDPR hidden within the logic of a replication, which will be more costly and more hidden. And so I think you can make it more explicit and put it as part of knowledge graph rather than leave it to just the applications to implement GDPR, applications that use knowledge graph. And so that was my answer to his question.
So
great.
May I?
Yeah, Panos, yeah.
So I will give the example of text kernel. So what we do is that our knowledge graph is about occupations and skills for the labor market. And much of the data that we use in order to process, but also to construct the knowledge graph from, are CVs, right? Curriculum vitae and vacancies. So CVs are really sensitive. Right? If a company gives us CVs to process, we need to be really careful what to do with them, right? Because they're sensitive personal data. So obviously the first level in the knowledge graph about GDPR is if you're going to explicitly represent persons, right? Medical records, this can be, or I don't know, financial transactions of individual people, right? You need to ensure that you have their, that's the explicit level, right? That you talk about David Amerland, and it says in a knowledge panel that David Amerland, I don't know, is a serial killer, right? For instance, which is
not true. Yes.
Okay. The second level, which is a more gray area, is when you use this data to derive facts for the population, right? To say, for example, that we analyzed 1 million CVs and 1 million vacancies, and we found that this particular age group is more skilled in, I don't know, in deep learning, for instance. This is not something that GDPR tackles, but it can be that you create biases out of this, right? Depending on what have you analyzed, and you have to really be careful for that. Not to be sued, right? But rather not to do any harm, not to create bias in your knowledge graphs. So we may be thinking that it's machine learning and deep learning that are full of biases, or at least are susceptible to biases, but also the explicit knowledge that we put in our graphs is also susceptible to that. So we really need to be careful.
Right. Okay. And there's an observation more an observation than a question that's appeared in the chat, and it's from Jose. And he's saying the idea of the semantic web as a worldwide distributed neutral knowledge base is still to be realized. And I think, Panos, this is what you were alluding to when you said that there can be implicit bias there. Jose says it is a continuous, endless battle between proponents of an open world, which is more beneficial to society on longer term, versus proponents of market-oriented walled gardens that have been successful in the last 10 years, like Facebook, Google, etc. And he says this poses a challenge which we haven't yet met, I suppose. Would anybody like to comment on this? Yes.
Yeah, I think there's yes and no. So inherently, Tim Berners-Lee, whom we do credit for this term, is very much into openness and creating products that are good for humanity and let everybody and everybody should contribute to a common thing and benefit from that. Versus, as Jose mentioned, the walled gardens that companies wanted to do. And that's where, for example, Facebook is on the web, but is not consistent with web's vision. Mm-hmm. Now, but I think, I use semantic web principles, and the company that I started in 1999, we had commercial products and services, web search engine in 2000 time frame. Well, it was a commercial company, and I did not make a knowledge graph that we built in the company public. So, the cost of building this knowledge graph is quite significant. And we had figured out amazing amount of automation. But by and large, I was giving a keynote to a conference of knowledge graph. There were 600 people in audience, and the guy who introduced me was from Google Knowledge Graph, work. He was just transitioning out from Google Knowledge Graph, but he told me that they have 10,000 people contributing to their knowledge graph. Imagine the amount of investment, and it also tells you clearly that so much of the knowledge graph work is manual, and that it also the same way so much of the work involved in removing hateful content is manual today. Right. So
can I reply to Jose for the? I think to comment on that. So when I said that, it's not. I understand, but it's not about when I say that the linking is not always good. It's not necessary. It's not that you have the evil corporations on the one hand and the and the hippies on the other. It's about the fact that there are both technological and human reasons why knowledge is not neutral. Knowledge is not neutral. We have to accept that, right? And it's quite neutral to talk about where was a person born in, etc. But when we start talking about politics, when we start talking about history, when we start talking about all these things, right? It's extremely difficult to create an objective, neutral truth about all these things, right? You have vagueness, you have uncertainty, you have ambiguity, you have context specificity. And one big limitation of the semantic web, which after 20 or something years hasn't really been realized, is the fact that we're still talking Boolean. We still have framework that talks about true and false, right? And even though there have been some efforts to try to reason with uncertain and vague information, it hasn't really been supported yet. So I cannot work with just Boolean, or if I have to work only with Boolean, I need to somehow constrain the potential range of opinions, because much of the knowledge, whether we like it or not, are opinions, are subjective opinions.
Right. On that score, Panos, there's a question which is right into your expertise. It's from Anahita, and she's asking, how do you connect ontology to knowledge graph in domain-specific use cases with complex and unstructured data? How much ontology is important? So there's two questions there, really.
Okay, so that brings us to the famous question: what is the difference between an ontology and a knowledge graph?
Definitely, yes, that would be brilliant.
Again, that how to say, the borders are blurry, and there is a specific reason for that. So if we take the semantic web talked about with OWL especially, tried to split the world between classes and individuals. Right, and then one idea was that individuals are the data and classes are the conceptual level. But in the end, this a class and individual is a role, right? So if I take the concept data scientist, I can make it a class, and all of us are instances of this, or I can make it a concept, and I can say that it's the profession of all of us, right? I can make it an individual concept. So really the question is about, so what is your ontology can be my knowledge graph and vice versa, right? Yeah, it really depends on the representation. My view is that what you have is entities. In the structured data, you have strings, you have terms, if you like. By giving, when you build semantics, you have to give meaning to terms, and you give meaning to terms by transforming them into concepts, right? So you have the concept, the term bank. How many meanings can it have? 20 meanings. You need to have 20 concepts, and start relating the concepts, right? Now, how much meaning you need to give? It depends a lot on what, on how big is your domain, how big is your ambiguity. The more ambiguous it is, the more background knowledge you need. It depends also on the methods you use, right? It's not a clear-cut question.
Excellent. I think that's that actually showcases the difficulties a lot of people are having in a commercial sort of respect in terms of getting their websites and their domains accurately represented and accurately appear in search queries in search, and sort of in a contextual sort of environment which reflects exactly what they do. And I think that actually shows why. And thank you very much for mentioning this. It's brilliant. How about the question of how do you connect ontology to a knowledge graph? I mean, how would you do that in a practical term? And I think, again, this is probably a domain-specific one, but if you sort of give a general answer.
And I gave a link to the paper that we wrote, which kind of we tried to make the distinction or connect the terms ontology and knowledge graph. And recently, one of the 3 Turing Award winner also used the word world model, which we had used it in our patent. The point is that, at least my view is that for any user, there isn't, you can use the word ontology or knowledge graph, but generally speaking, knowledge graph representations are not as rich as what we used to call ontology. And generally speaking, ontologies were largely model represented in OWL language or something of that kind of description logic. And generally speaking, ontologies represent ontological commitment. A very fundamental aspect of ontology definition itself. The 2 aspects of ontology is that there is an ontology commitment. That means there is a buy-in by the community or by those who are going to use this ontology. That was a fundamental aspects of ontology engineering work. And in the case of knowledge graph, people don't care about it, or it is India. And that is where it comes. You use knowledge graph, within an enterprise in a walled garden. And you are not looking for seeking the, you are saying this is, my company's view on it, and this is how industry will use what I define, and take it or leave it kind of thing. So you have market power, and you're exercising that to exploit that, but there's no, effort. So in general, you can make a sense where you want to call it ontology or knowledge graph, but at the fundamental level, purpose for both of them is the same, that you want to infuse knowledge in understanding the data, in processing of the data, in associating meaning with the data, in gaining insights from the data. Knowledge, just the same way that in deep learning, neural network, statistical processing, pattern recognition plays a fundamental role in what they do. Knowledge plays fundamental role in making connection between whatever you have in the data with what people want to call conceptual representation, and then make connections. So the moment I say that this string is David Emerlin, and that he has this company, that is this concept, along with that I immediately get the knowledge that he works for this company, he has made these contributions, so on and so forth. That power you get it whether you call it ontology or you get it knowledge graph. At the minimum, for both of them, the most important construct is relationship, label relationship. So name graph. So earlier there was a very interesting point Ben made about label property graph versus RDF. The common part is still relationship and a label relationship, and there's some more that people have not found that valuable. The practical world and industry who build enterprise knowledge graph have not found all the representation and challenges of RDF to be worth the effort. And that's basically why it has come down to. That you get 90% of things with lower cost by using label graph. So my own company, I had research papers in 1990s that used knowledge graph, 1996, 1998. But when I implemented, our knowledge graph, we did not use RDF as a whole. We used RDF Lite.
Right. Okay, and on that score, yes, Panos, by all means.
So I agree on that. What Amit said, indeed, ontology is a commitment, right? But I'd like again to say that, like if we take DBpedia for instance, what is the ontology of DBpedia? So DBpedia has some classes, like 300 or 400 classes, right? But this is not the ontology. So every time DBpedia defines a concept, for example, data scientist, which is not necessarily a class, but a page, a resource, we still need to have a commitment there so that we all agree what a data scientist is. So it's not that what I want to clarify is that people should not think that there is a distinction between ontologies, just the classes and the axioms in all, and all the rest of the entities do not have ontological commitments. The whole goal is for this to have also commitments. And this is something that we need to address. A second thing about, I think there was a question about labeled property graphs and RDF. Indeed, the main difference between these two, for me, is the predefined semantics. So the thing is that, for instance, RDF gives me a construct that is called RDFS subclass, for instance, right? Which has a meaning that we all agree what it is. Whereas in I can also implement that in my Neo4j, in my property graph. It's just that it's not going to be a standard, right? So that, I think, is what makes one framework a bit more semantic than the other, as long as this commitment is respected. Because if this commitment is not respected and people abuse RDFS, the constructs of RDF of all, then we're not getting semantic interoperability. And this is happening. And one key example, one basic example is the all same as. Try to see how many mistakes are there.
Great, and I think that's really cool. And there's one more question which has come in, and perhaps Theodora is best suited for this. Theodora has written about the way that text morphs across the web in terms of definitions and how we use it. And the question is text constantly mutating, or can we somehow fix it as we go across the web in terms of definitions? Theodora?
No, we can't fix it. We don't have to fix it. We're not in the business of fixing meaning, but rather of dancing with it. And that's why I so much like the semantic web, which Panos doesn't see the way I do. Still,
on the back of that, very quickly, very and that Theodora is, if meaning is constantly in flux, then how do we communicate across different cultures or across different contexts?
So it depends. This is a pretty deep question. I will give you a simple example. A person is married to person A is married to person B, and the two are in marriage relationship. Then there is a divorce. The two persons are no longer married, and person A marries person C. There's another person with a relationship. In between, there is no relationship with any other person of the same kind, and so on and so forth. So one of the many aspects of this transient relationship is the fact that things evolve. But this is just one of many aspects of the evolution and changes in the meaning. And there's more that you can think about. It's a pretty challenging and deep subject. The meaning of it goes even more difficult. So, for example, you would expect that the relationship of marriage has a more reliable and long-term relationship. But as we know, in our lifetime, in last 20 years, even that has changed, right? what used to be called marriage or between man and woman is no longer a restriction, and in fact in many countries is legally accepted as such. So all the meaning at both the schema level can change, as in the example I said of the marriage, and the meaning at the instance level can change, as in the example of person being married to person and divorced, and other things can change also. And there are more of those things we probably don't have time for.
Okay, thank you very much. And we are indeed running out of time now, despite the fact that all of you tried to put in as much depth to everything. I think we barely scratched the subject matter here in the conversation, and there's probably enough material in some of the questions, and certainly in your knowledge, to go on for several hours on this. However, we are getting near the end of the session. So, George, would you like to sort of have a final word here?
Yes, well, first of all, yes, as you said, David, we only just scratched the surface, and we could actually go on for a long time. But it's a complex topic, so maybe we can have a part 2 at some point, and hopefully with better sound on my side. I apologize for that; it was not in the plan, but you know how live shows are sometimes.
Yes, indeed.
So. Anyway, since we have to prepare for the next session, I would just like to thank all of you for your insights, and well, hopefully we can continue the conversation next time. Thank you.
And thank you very much to all those who participated with their questions.
Yes, thank you very much all.
Take care.
Bye-bye.
Bye.
Bye.